Okay, now so I'm back with section 4.3. This part 2, and we try to solving a system of equation with using matrices. So let's start with problem examples 4.10 here. I'm gonna solve the following system of equation using the augmented system and Gaussian eliminations. So what is augmented matrix? Okay, so let me explain to you that for the augmented matrix, you just put out all the coefficients. So let me know here. Just the coefficients. And constant. Okay, and you can see that all the coefficient in the first row was this is hidden number 1 here, right? 1, 3, 5, right? Let's put out 1, 3, 5. Okay, and the constant in the right hand side gonna be 45. So the bar that separate is in between two sides. You can think it's like a equation to separate it, right? Okay, so maybe use the next one. The next one gonna be 2, right? And then -2, right? And then 1, 0, right? And then 4, right? You can it's come from this equation, and I put out all the coefficient and the constant, right? Keep in mind that we have the bar over here to separate the constant and the coefficient, right? This bar separates the coefficient and constant. So I will explain more that is also represent the variables x, y, and z. Okay, so it also can represent the variable x, y, and z. Okay, maybe I'm gonna variable matrix. I'm gonna write the matrix. And I explain you later. Okay. The last row, we're gonna have 3, 1, y, 2, and then 25, right? So you can think that is similar, like we are right this using matrices by multiplication between two matrix, such as the coefficient of the left hand side. So 1, 3, 5, 2, -2, 1, 3, 1, 2. With the column matrix of variables, which is x, y, z here. And make the last column, which is constant, 45, 4, and 25. Okay, so if you do this, you will have exactly the same back to the original equation. Okay. However, we can't just see that you just put out all the coefficient and constant down here, right? And separate between the coefficient and constant by the bar here, right? Okay, so that is a way. Okay, now let's we go ahead and do step 2. Or in part B, I want to use row operations, which is Gaussian eliminations, to put this augmented matrix into the triangular form. Okay, so the triangular form. Yeah. Okay, so last we just go ahead and put down all the number first is into here first, right? Okay. All the number first. All right. So what I want to do for the next step is I want to eliminate all the other all the all the number under the first entry of the first row. So we mean I want to have I want to put zeros here. I want to put 0 here. I want to put 0 here. So similar like I did in elementary operations, I want to use the row or the equation. Say I wanted to change equation 2, right? Equation 2. I will have to. I'm dealing with just coefficient only, so I just see that these two need to minus something time or add something with multiply by E1. I know that it's going to be -2 times E1, right? So that's mean E2 minus 2 times E1, right? So at this point, you can think like, oh, if you multiply this the top by -2, right? You will end up maybe I will put down some instead of using E, I'm going to use R as a row. I'm going to use row, right? Row 2 in here was 2. I actually going to copy this right? And I need minus 2 row 1, right? 2 times row 1. So you know that's row 1 for this guy, right? So you multiply by -2 with it, so we're gonna be -2 here. 3 times -2 gonna be -6, right? 5 times -2 gonna be -10, and 45 times -2 gonna be what? -90, right? So if you do if you adding these two, you will have new row 2 as new row 2 at 0 here. This is -8. It is -9. And it is -86, right? 86. Okay. So then I'm gonna put down this into my new row 2. And I keep my row 1 at the same before. All right, because I am using that. Okay. Let's make this red and working. Okay, so I will also eliminate the number 3 here to be 0, right? So I'm changing row 3 by adding something multiplied by row 1. What is that? It should be -3, right? So -3. -3 times row 1. Okay. So let's put down. Let me move this a little bit over here. I will say row 3 here. Make it smaller. Oh, too small. Is it good enough, right? Then I subtract for 3 row 1. All right. So copy down row 1. So row 1, -3 times 1 gonna be -3. -3 times 3 gonna be -9. -3 times 5, -15. -3 times 45 gonna be -135. Okay. Then I will adding them together to get the new guy. New 3, which is 0, -8, -13, -110. Right? And I put out this guy to over here. Just okay. So that is for my my update matrix. Eliminate the first column over here for second row and third row, right? Okay, so now I'm gonna move to the next step, which I try to eliminate the y term in the third equation. The y term now will actually be this -8 here, right? And the goal right now is I want to put zeros here. All right, the goal is I want to put 0 here. Maybe I make a red color. So it's going to be green one better. Okay. So how to do that? I will use the equation, the row number 2 here, to eliminate this one. Right. So I'm changing row 3 again by adding something multiplied by row 2 only. I don't touch row 1. Okay. So how? What I'm gonna do for row 2? I saw that it was -8 and -8 here, so that I just need to multiply by -1 for row 2. So which means I minus 1 time, or I should minus row 2 here, right? So I will get the new guy down here. Okay, so we'll just copy down the first row. Okay, second row, copy down. Third row, I'm gonna do row 3 now. Okay, and I minus row 2, which is 0. Copy this. Copy this. And I change the sign. Change the sign. Change the sign. That. And I will just adding them together. We have new row 3. We're gonna be 0, 0. -13 plus 9 will be -8, right? Let me see. Make sure. -4. Sorry. And last one will be -24. Okay, so we'll copy this one. And put out here. Here we go. So now, if you draw 3 lines bounded, all the non-zero number in the left-hand side of matrix, so you will see this. Right triangles. Okay, so this make a right triangles. So this give us, this mean that we have triangular system. When you put back when you put back from matrix to the system. Okay, and this form we call REF, row echelon form. row echelon form. With noted by REF. I'm gonna just so after that we can go back to triangular system, right? Okay. So let's go back to that chain, convert this back to the triangular system. How to do that? You just chain this like, using all the coefficients there. You have like x plus 3y plus 5z, 5z, right? 5z equal to 45. And normal x, so I have negative 8y minus 9z equal to negative 86. And the last one going to be negative 4z equal to negative 24. So these will be triangular system that you need. Okay, now we're gonna use back substitute to solve the equation for z first, right? And then y and x. So let's start with equation number 3, which is saying that negative 4z equal to negative 24. So you're gonna have z equal to negative 24 divided by negative 4, which give us z equal to 6. Then for equation number 2, we move to equation number 2, we say negative 8y minus 9z equal to negative 86. So I can substitute and make negative 8y minus 9 times with 6 equal to negative 86. And that means negative 8y minus 54 and equal to negative 86. Adding both sides by 84, right? 54, right? You will have negative 86 plus with 54, and that's give us as negative 8y equal to actually gonna save a little space. And 8y will be equal to what is that? 32, negative 32, right? Then lastly, you're gonna say y will be equal to negative 32 divided by negative 8. We give you 4. All right, y equal to 4. Okay, let's come to equation number 1. We have x plus 3y plus 5z equal to 45. Okay, so what we want to substitute as x plus with 3 times with y, which is 4, plus with 5 times with z, which is 6, and then equal to 45. Simplifies, have x plus with 12 plus 30 equal to 45. So then we have x equal to x plus with 42 equal to 45. Then we have x group equal to 45 minus 42, which is 3. So x, y, z solution will be 3, 4, 6. All right. I'm gonna highlight the answer. So so we're gonna move to the next exercise and see what happened, okay? Oh, actually, I will also show you with another methods using calculators. We can come from the original one here and right away come to here by using calculators. So let me show you by using calculators with REF, right? So let's we using I spell here, so using TI-83, right? So we may have to go to the calculators and go to second matrix, right? So put out second and first matrix, seconds matrix, and then voila. And then go to the edit and maybe input edit and then maybe enter number one. Say enter one we're gonna use the matrix A, right? And then we input chain dimension first. Chain dimension to be this is gonna be 3 by 4, right? And input as augmented matrix. So let's see. So enter here 3 by 4. Yep. So let's input all this, right? So we have 1, enter 1, and then 3, put out 3, 5, put out 5, 45, enter, and then 2, and -2, 1, 4, 3, 1, 2, 25, right? Enter that. So just want to make sure that you may have to recheck all the input might be correct, and that you may get wrong later. Okay, so also I want to tell you that for -2 you must using this negative, don't using this minus for 2 and -2. Okay, so now after you finish that, you're gonna go second and quit, right? So put out second and quit. Maybe second quit, and then go back to second matrix, and you will have second matrix. You will use names and number 1, right? So wait a second, no, this one. Second matrix, you're gonna use the math. Go to the math and go to the yet. Okay. Yep. And then enter that. Enter, and then go back to second plus matrix again. Go to the name and one matrix A. Enter. Okay, so second matrix name 1A. Enter. Okay, and then close the parentheses and enter. So close that. Right, enter. And now your outcome will be the triangular will be row echelon form. Row echelon form as above. So so it's maybe a little bit different from equivalent, or maybe equivalent with the row echelon form above as below. We may need to have an optional step. Optional step as change it to be fraction form. So click math and 1 plus enter. All right. So let me show you. So now I have some fraction thing or decimal things. Click math and 1 here. Enter. So you will have, we will end up with the matrix as 1/3, 2/3. I use other color. One third, 2/3, and then 25. We have 0, 1, 13/8. 13/8. 55. 0016. 0, 0, 1, 6. Okay, let me check to make sure if it is correct. Okay, actually they need more. So 25/3, 55/4, 55/4. So we're gonna make something like black here, borrow here. Yeah. So this is another way you can use, but you have to show me all the steps I have typed over there. Right, you have to write all the steps and get to this. Okay, so maybe I'm gonna erase this and I say from here. Okay. So you can write like that, and you can type like that, and then show me the way. Show me the way with all that step I have typed above. When you use, calculators, and you will end up with, changing back to the system as x plus y 1/3 y, and then plus 2/3. Oh, z. Oh man, this is gonna be equal to 25 over 3. And the second one gonna be y plus with 13. Oh. Over 8. E equal to 55 over 4. And then we have z equal to 6. So as you see that, I right away have z and equal 6, and then I'm gonna direct. I wanna vector with you to the second one, and then find y. It's look actually at this point, but think about if you multiply by 8 later for the whole equation number 2, you will end up with no worry about the fraction form, right? So yeah, so this is one of the very quick way for you to handle the system when you're using matrix and using calculator together. Okay. All right. So now you can go ahead and try to use maybe Zohan their own way for this, and maybe try with calculators. I will allow both way if you want to go with, but for part A, I absolutely gonna say you must put out the augmented matrix as say 1, -2, 4, 20, all right, and then the next one gonna be 5. Oh no, this is y, right? So this is 5, it is 8, and it is 1. The last one gonna be 6, -2, another -2, and last one is 38. Okay, go ahead and pause my videos and see and try it in 5 minutes. Maybe try both way calculators and then hand way to see and compare and check with my answer. Okay. All right. So you see down here, what I did was I using row 3 minus 6 times row 1, because row 2 have been, eliminate the first coefficient over here to be 0. And then I just worry about number 6 here to be 0. So I change that to be the new one as 0, 10, nav 6, 10, 6, and nav 82. And you see the way I did was here. And also after that, I keep going with eliminate this number 10 here to be 0, right? By using row 2. So I'm going to using row 3 minus 2 times row 2 since I have 5 and 10 here, right? So I will have I using as I work here, and I get row 3 will be 0, 0, negative 42 and negative 84. Okay, so now as you see, if you draw draw 3 lines to bound all the non-zeros coefficients, you will see a right triangles. So this is this REF form, right? From here, you're gonna make come back with a triangular system. Okay, so you will have the system as x minus 2y plus 4z equal 20, and then 5y plus 8z equal to 1. And last one going to be negative 42 equal to z equal to negative 84, right? So go ahead and try to use backside material to solve the equations, okay? So you try to solve it by back solve later, but I will also show you by the way I use for REF by TI-83, and I end up with the matrix as over here. All right. This is also an REF matrix. So when you change back to the system, you will have x minus 1/3 y, and then minus 1/3 z equal to 19/3. And then the second one will give you y minus 5 plus 8/5. Z equal to 1/5. The last one is z equal to 2. So you can using back substitutes, you will have y plus 8/5 times 2 equal to 1/5 now, right? You can have 5 side. You want to get rid of the fraction form. If you don't want the fraction form, you have like 2y, sorry, not 2y, multiplied by 5 both sides, right? 5y plus 8 times 2 equal to 1, right? So that's giving you 5y plus 16 equal to 1. And that's give us, let's give us 5y equal to negative 15. So that you can say y equal to negative 3 if you divide by 5 both sides. Okay. Now you can highlight this. Highlight the Z2, highlight y. Now you can just substitute z equal to y equal to negative into equation 1. So we have x minus 1/3, 1/3 y negative minus 1/3 is 2. 19. I will leave you with multiply by 3 both sides, have 3 sides, plus with 3 minus 2 equal to 19. Then you have x with equal to 6. So the answer for this one should be 6, -3, and 2. All right, so that is a way to solve for the matrix by REF, row echelon form, and then back substitute, right? Okay, so we're gonna have application of matrix. Let's move on. So we have example 4.11 application of matrix multiplications. We have 2 club soccer team, the Wheelcast and Mudcast, are hoping to obtain new equipment for an upcoming season. The table below shows the needs of both teams. So as you see down here, we have the table with 3 columns, but the main 2 columns is for Wheelcast and Mudcast, and then we have 3 rows which present for goals, ball, and jerseys. There is some information that you may consider as the goal cost $300, a ball cost $10, and the jersey cost $30. How can we use matrices to find the total cost for the equipment needed for each team? So in this case, you will set up matrices multiplications. The first matrix will be 1/3, which for the goal as $300, $10 for the balls, and $30 for jerseys. Let's say goal, balls, and jersey. Yeah. The second matrix is 3/2, which is 6. I'm gonna, I'm gonna use this Wheelcast. Maybe, and then this is Mud. Okay. Maybe Wheelcast and Mudcast only, like this. Okay, so we have 6, we have 10. Can we here? No, it doesn't work. So the next one will be 30, 24. The last one will be 14 and 20. Okay, so you multiply between to this matrix, you will get the answer as 2520 and 3840. So you can think like 300, 10, 30, okay. Then multiplied by 6 plus with 10 times with 30 plus with 30 times with 14, right? What is it going to be? 2520, okay? The second one will be, I'll copy this one. Over here, 300 times with second column of the second matrix, 10 is 10 times with 24 plus with 30 times with 20. That's give you 3840. And you can also use calculator to handle this, okay? So the total cost for equipment for the wheel card, this is wheel, this is mud, is 2520. And for the mud card is 3840. All right. And this doesn't seem so complicated with 2 teams and 3 categories. However, if we had 50 categories in our list and 10 schools, then multiplying by much is easy to do on a computers, streamlines the process. So check out the exercise on the next page, C, okay? All right. Okay, you guys can pause my videos and then try it in 5 minutes and then come back to check the solutions. Okay. All right, so you can see that let me see. We have hint in here for matrix L, which is 2 by 3, right? So this for labor hours per computer. So I'm gonna just put out 2 rows here. 3, 1.5, 0.5, 4, 2.5, 0.75. And the W is going to be the hour wage, right? 3 by 2. So make 3 by 2. So 14, 13, 16, 20, 12, 10, right? So then now we can do, we can do compute products, LWs by calculators. So I would recommend that you want to do by calculator. So let's turn it on, show you. So clear this up. Second matrix, go to the edit, change the A, change the matrix A to be 2 by 3, that's L, right? And then 3, 1.5, 0.5, 4, 2.5, 0.75. Okay, so I'm quit this guy. I'm go back to the matrix again and edit the second one for B is W's. And I change it to be 3 by 2. and then 14, 13, 16, 20, 12, 10. I'm done. Get out, and I do matrix again. Name at A is L, right? Multiplied by second matrix B. All right, enter that. You now get 72, 74. Do that. LW will be 72, 74, 105, 109.5. So how do you say the 2x1 entry, 2-1 entry, which is row 2, column 1, is 105. This meaning what? This meaning the totals cost for production production. Actually, I'm gonna move this down. Okay, here. Production. A desktop in country A is $105. Okay. So as you see that you can do multiplication very quick with calculators. And we're gonna have the next one by check the commutativity, right? Commutativity. Okay, so we mean like I said before, A times B is not equal to B times A in matrix. Okay. So I would like to let you guys work on this one. You can use calculators. You can use the hand. Doesn't matter to me. Just show the answers and then tell me what you have, right? So the answer for the first one, I will type -7, 10, and then 30 and 11. So that is for A and B. For the second one, going to be -9, 10, 10, 4, -8, -12, 10, 4, 21. So as you see that A and B's are not equal to B to A. Okay. And the important is matrix multiplication is not commutative. So as you see here, in general. Okay. So we can have matrix multiplication follows similar rules of associativity and distribution that we use when multiplication real number. So Pro-T will be all below here. Okay. So as matrix multiplication associative will be product between AB and then C can be write as A times B, A times the product of B and C. Okay. Also, metric multiplications is also distributive, so you can do like C when C multiplied by the sum of two matrices A plus B, you can distribute it and to be C times A plus C times B. And you can do like A plus B, sum of A plus B and multiply by C, you can distribute it to be A times C plus B times C. Okay. So let's move to the next part. We're gonna skip this part. I don't wanna solve for this one by inverse, so I don't want to cover this one. Let's see. There's some good one here. No, it's all talking about inverse, so I'm gonna not cover this. So we'll skip all this. Okay. Anything else? We have actual practice here. I would like to let you guys work on this one. And I can give you the answer key will be, so S times C equal to, you can use calculators and get 1,290,000, and other going to be 1,800,000. Okay. And 1.1, I mean, sorry, 1 entry 1 will be 1,390,000. No, 1,390,000. Right. And mean what? You're gonna go ahead and try that. Second one will be 1,080,000. 1,800,000. Okay, so go ahead and try to explain. Yeah. It's a key put out here. Okay, so I'm gonna just finish my chapter 4 here, and we'll see you in chapter 5 later. Good day.